Another special rigid body structure is the 2-force member and 3-force member. Okay, what is the difference between these two rigid bodies? Okay, as the name goes, 2-force member simply means that there are two forces acting on the rigid body. Okay, and accordingly, 3-force members means that there are three external forces acting on the rigid body. As simple as that. For a 2-force member to be in an equilibrium state, there are certain rules that it needs to follow. Okay, the first one is that the two forces must have the same magnitude. And the second one, it have the opposite direction. And the third one is that the line of force too is in the same line of action. So these are the fundamental basis in deciding the forces condition when the 2-force member is in an equilibrium state. Okay, so on the other hand, for a 3-force member to be in an equilibrium like this, there are three forces acting on the beam. So in one case, all line of forces, if we project the line of action to, it will intersect at one point called point O, so that the corresponding summation of moment would result to 0. Okay, but in certain special cases, the forces can also be in a parallel direction. So in this case, this is also an equilibrium state whereby there is no possible intersection point between all the three forces for a 3-force member. Okay, now let us look at this example. In this example, given that this part is an assembly, consists of two components, which is level ABC, this one, and also a short link BD, okay, which is this one. This level ABC is pin supported at A, okay, pin supported at A. So if A is pin, okay, if A is a pin, you notice the shape of A is also equivalent to the shape of the support at D as well. So the joint D is also a pin. So if you refer from your support reaction table kan, if that part is a pin like this, okay, buruk pula saya lukis ni, but never mind, I just want to show you the effect of a pin support reaction. So it can be resolved into vertical force, which we call it Fy, and also horizontal force, which we call it Fx. Okay, accordingly, we can also represent the support reaction of a pin with a single force juga, whereby Fx and Fy ni kita boleh merge actually to become a corresponding resultant force. Okay, we can actually also rewrite the reaction force for a pin using a single line like this. Okay, so in this case, I know my D is actually a pin. So if I were to draw the free body diagram, if I were to free up the components of this particular assembly, so if this is my support pin of BD, and this is a pin, so I want to draw the support reaction using this kind of support reaction effect. Okay, so if this is my force at D, so if you notice, this is actually a 2-force member. Okay, so for this 2-force member to be in an equilibrium state, then the corresponding force at the opposite direction must have the same magnitude. If we call it FB, then FB must be equivalent to FD, sebab it must be the same magnitude, except that it have different direction, opposite direction, and must be at the same line of action. Okay, so this is an example of a 2-force member. So now we are actually interested in ABC punya level, not BD. So if I were to again redraw the joint of ABC over here, I know at A is actually a pin. So I can draw the resultant force of a pin probably like this. Okay, so I'll just call this FA. Okay, again similarly saya use this kind of reaction, force reaction. Okay, how about point B? Okay, tadi point B dia ke atas kan? So, the reaction biasanya adalah opposite. So, this is the force at point B. Alright. So, now how about point C? Kita tahu dekat point C, that is a horizontal kind of force. The magnitude of 400 Newton. Okay, now if you recall, for a three force member, this is a three force member. Dia ada three force at A, B and also C. So for a three force member, if we project dia punya line of force to further, it should meet up at one particular point. Let's call it O. Okay. So now the question actually asks you to find what is the resultant force at FA. Okay. Macam mana kita nak buat ni? Okay, now that we have drawn the free body diagram, the next thing is we need to solve the equilibrium condition of this free body diagram. So, biasanya kita akan solve the equilibrium condition systematically lah, using the fx direction and then summation of all the forces in y direction, and then kita apply pula moment. So, in this case, sebab ada forces yang sengit-bengit macam ni, sengit macam ni, let's just resolve it into an appropriate x and y direction. Okay, so I use a different color. So if this is my FA, okay, this is my FAY, or I can also rewrite it as FA. Kita nak ambil angle yang mana? Let's say kita ambil angle yang sini lah. Let's call this theta. Let's call this angle theta. So I need to find FA sin theta. Okay, we just leave it as it is sebab memang ada information yang kita tak tahu. Okay, on the horizontal side pula, okay, if we resolve this FA into 2, tadi kita dah buat untuk FAY. So, untuk FAX is equivalent to FA multiplied with cos theta. Okay, theta is unknown at this point. But it's okay, Relax. Kita cuba break down all the force yang sengit-bengit itu into x and y direction dulu. Okay, kita buat satu-satu. Okay, now another force yang sengit-bengit is the FP. So, if I were to resolve it over here, okay, this is my FBX. And do I know the angle over here? Actually, we do. Macam mana kita tahu? It's not given. Okay. You look carefully at your DB link ni. Okay. DB link ni, the length over here is 0.2 meter. The length over here is also 0.2 meter. So, if I were to join these two lines like this, yang ni dengan ni lengthnya sama. So, it means that the angle over here and over here is the same. So, if this is 90 degree, then the angle over here would be 45. Sorry, tebal pula dia punya font dia kan. So, the angle over here would be 45 degree. And this one is also 45 degree. Sebab dia segitiga kaki sama ni. Okay. So, from this information, we know that this part is 45 degree. If we apply the trigonometric function over here, FBX is equivalent to FB multiplied with cos 45 sebab dia dekat sebelah. So accordingly, this is not FBX, it's FBY. It's in the vertical direction. Okay, accordingly, we can resolve this as FB into X direction juga, whereby FBX is equivalent to FB sin 45 degree. Okay, now that's done. Ada lagi tak force yang sengit-bengit? Tak ada. So now the next thing we need to do is we need to find what is the value of theta over here. Theta is unknown. So if I were to redraw dia punya line, if I were to project this line over here, and I just draw a triangle like this theta is equivalent to this theta kan? Okay. So do we know the length? Can we use the trigonometric relationship to find theta? So, possible if we know all the measurement or all the dimension given. Okay, let's see. What is the information given? Dia kata from point D to point B or from here to here is 0.2 meter. Okay. And then we know from point B to point C is 0.5 meter. So this length is 0.5 meter. Okay, so the overall length from here to here is 0.7 meter because 0.5 campur dengan 0.2. Okay, how about this part? What else? What are the other information that we have? Okay, so we know this is 45 degree. So using the mathematic punya law tu, the opposite angle will also be 45 degree. And we know that this is a segitiga kaki sama. Every time you nampak je 45 degree, maknanya length dekat sini dengan length dekat sini sama. It means this angle will also be 45 degree. Do we know the distance from C to B? C to B, yes, we do know the distance from C to B, which is 0.5 meter. So, because of this little cute triangle kaki sama ni, so kita boleh tahu that the distance from C to D is also 0.5 meter. Let me just erase this. Okay, let me just erase this so you don't get confused with so many ugly sketches over here. Okay, so again, we know the distance from C to D is 0.5 meter. Macam mana kita tahu? Sebab dia segitiga kaki sama. Okay, dia ada kaki sama. That's why angle dekat dalam ni pun sama. Okay, now what else? What other information do we know? Do we know this distance? We don't know this distance, but we know the distance from the level punya straight area to point A is 0.1 meter. So, from this to this point is 0.1 meter. Okay. So, point CD is 0.5 meter. From this point is 0.1 meter. So, easily we can find the distance over here to be 0.5 tolak dengan this 0.1, and we'll get a corresponding distance of 0.4 meter. Cool. Now, we have complete information for our trigonometric function. Okay. Whereby if I were to redraw the triangle like this, okay, harap you boleh nampak, you can relate this triangle using trigonometric function of tangent theta. Tangent sama dengan tentangan, which is 0.7 meter divided with sebelahan dia is 0.4 meter. So you can get a value of theta in the value of 60.2551 degree, and that is the theta angle. So bila dah dapat the theta angle to be 60.2551 degree, then you can actually solve for this and also for this. Okay, now all the information are ready, then only we can apply equilibrium condition for our ABC punya level. I know it may look very confusing over here, but then you just try to bear with me, ya. Okay, so in equilibrium, Allah, jadi highlighter pula dia. Okay, let me just change the mode. Okay, so in equilibrium, as usual, I would like to approach it systematically lah. Usually, I would start with the summation of all the forces in X would be equivalent to 0. So, tengok ada berapa banyak forces dekat X ni. So, that is the FAX, there's the FBY, and also there's the 400 Newton. Ada lagi tak? Tak ada. Ada 3 benda je dekat sini. So, if I were to rewrite all this expression into my equilibrium equation, the first one is FAX. So, I'll just rewrite it as FA cos theta. Theta tadi kan kita dah dapat, which is 60.2551. Okay. And then, it's positive because it's to the right. And then, minus with the FBX, which is FB sine 45 degrees. And then, we have to plus with the 400 Newton. Plus 400 Newton. So, ada lagi tak forces in X direction? Tak ada. So, that's it. So, all these forces should sum up to 0. Okay, so if I were to rewrite and calculate all this using the calculator, I would get a value of 0.4961 FA minus with 0.7071 FB. Okay, I'm just rearranging all the unknowns to the left side. This should be equivalent to negative 400 Newton. Okay, so kita tak boleh solve lagi because there are two unknowns or two variables. So let's just call this equation to be equation number 1. Okay, now since kita tak boleh nak solve dia lagi, we have to create another equilibrium condition, this time around in the y direction pula, whereby the summation of all the forces in y is equal to 0. So let's see, ada berapa banyak forces in y. So there's the FAY over here, or FA sin theta, and then there's the FBY, and oh, that's it. Ada dua benda je dekat y direction. So if I were to rewrite it over here in my equilibrium condition for y, so I can write as FA sin theta. Theta kan kita dah kira tadi, which is 60.2551, and then it's positive because it's pointed upward, and minus, this is downward, minus with the FB cos 45, minus with the FB cos 45 degree, and the summation of these two forces should be equivalent to 0. So now, if I were to use my calculator, I can simplify this equation into 0.8682 of FA minus 0.7071 of FB. So ini sama dengan kosong. So this is the second equation. So now, kalau you tengok dekat equation ni, you can actually solve it using persamaan serentak. Tapi when it involve like 4 decimal places like this, sometimes jadi macam susah kan nak jadikan equation tu sama, dan jalan kerja jadi lagi panjang. So right now, what I want you to do is to utilize your scientific calculator to accurately, to easily calculate the value of FA and also FB. Okay, now if you want to use your calculator to solve for simultaneous equation, you have to make sure your equation is in the form of this. A1x plus B1y equivalent to C1. Okay, so in this case, kalau kita nak tengok tally ke tak dengan equation 1 ni, your A1 would be 0.4961. The x is the unknown, the first unknown. So in this case, our first unknown is FA. So this is our x. B1 is negative 0.7071, and the second unknown is y, which is this FB, okay, and so on and so forth lah. So accordingly, the second equation pula must have the form of A2x plus B2y equivalent to C2. Okay, so you match with the second equation. So now, for you to use the calculator punya mode tu, so you kena tekan, depends on the model of your calculator lah. So for my calculator, you kena tekan mode 3 kali, and then only you choose item number 1, and then you just jawab je dia punya equation accordingly. So I'm going to demonstrate how you can use your calculator to solve for simultaneous equation. Okay, so for you to use your calculator to solve for simultaneous equation, you tekan mode 3 kali. Mode 1 kali, 2 kali, 3 kali. Okay, so you nampak sampai dia ada this particular function, you choose 1 for equation. Okay, so saya tekan 1, and then the calculator will ask you how many unknowns there are. So in this case, unknowns kita ada 2, which is FA and FB je. So we choose 2. Okay, so dia akan terus tanya, what is the value of A1? So based on your equation format tadi, your A1 is 0.4961. Okay, bila dah 4961, 4 lagi 1. Okay, so kalau dah masukkan value tu, you tekan sama dengan or enter. So dia akan tanya pula, what is the value of B1? So B1 is negative 0.7071. So tekan lagi sama dengan. Okay, and then they will ask you what is C1. C1 is negative 400. Okay, tekan lagi enter or sama dengan. So they will ask you the next equation. For A2, the value is 0.8682. Tekan enter, and then your B2 is negative 0.7071. Okay, and then the C2 is 0. Okay, now the magical thing will happen whereby you akan dapat your value of X to be 1074.98, and then kalau tekan lagi equation sama dengan ni, you will get 1319.8946. Okay? Okay. Based on the solution in the calculator tadi, so you can say using calculator, the X value which actually represent for FA is equivalent to 1074.98 Newton. Okay, and the value of Y tadi yang you dapat, which is the value Y which represent the magnitude of FB, is equivalent to 1319.89 Newton. Okay, so ada negatif ke tak ada negatif? Okay, kalau dia both positive, it means your initial assumption is correct. So this is how you solve the equilibrium condition and the simultaneous equation using your calculator. You can save up a hell lot of time if you utilize the power of your scientific calculator. Okay, dah siap.